Okay, now we want to talk about another reason for climate change, and this is called albedo. And what this is when light from the sun hits the earth, some of it hits water, some of it hits land, some of it hits the ice caps, places where there's lots of ice. So water tends to absorb light. The land absorbs the light and it also reflects some of that light. And then ice doesn't tend to absorb light much, but it does reflect light a lot. So we've got these three different kinds of surfaces that light can fall on. So let's imagine that you have a planet that has a lot of snow on it. So here's a lot of ice that is covering the surface of the earth. And so that would mean that more light is going to be hitting the ice than is going to be hitting the rest of the earth. And that means that this energy, which normally would be heating up the earth, is going back into outer space. So that means that the planet is going to get colder. If the planet gets colder, that means it's going to snow more. If it snows more, then that means that more of the planet is going to be covered up with ice, which means it's going to get colder. Now, what about if it goes in the opposite direction? So let's say that the planet gets warmer, then the ice is going to melt, and that means that more of the land is going to get, and the oceans are going to get warmed up, which means that the climate is going to get warmer. If the climate gets warmer, then that means more of the ice is going to melt, which means there's more land and ocean to absorb the light, which means it's going to get warmer still. So this is an example of a positive feedback loop. So the results of this intensifies the effect that's causing it in the first place. Now this has a 10,000 year cycle, which corresponds to the ice ages. So that ice ages have been occurring for the past few million years here on the earth, and they have roughly a cycle of about 10,000 years. So every 10,000 years it starts getting cold, and then it starts getting warm again, and then it starts getting cold again. And right now we are in a warming cycle. We don't know how long that's going to last before we go into another cold cycle in the ice ages. Okay, let's talk about the some astronomical things that are going to be happening. So the Earth is tilted at about a 23-degree angle. Okay, now because of the gravity of the sun over here, the Earth precesses like this. Now it takes, however, 26,000 years for the Earth to make one of these motions, to precess just once. You should be familiar with the concept of precession with a top. So if you take a top, you wrap the string around it, you pull it, you put it on the table, you might notice it's wobbling. Okay, that's what precession is. In the case of the top, it's the gravity of the Earth pulling down on it that's causing it to wobble. In the case of the Earth, it's the gravity of the sun pulling on the Earth that's causing it to wobble. So what difference is this going to make? Well, as long as it doesn't change the angle that we are tilted at, it doesn't make that big of a difference, because you would still have the same seasons. You would still have a summer and a winter and a spring and a fall, but the timing would be different. So that let's say that today it is summertime. Okay, in 13,000 years, when the Earth precesses over to here, then winter time is going to be in 6 months. So the seasons will be reversed. When it's summertime today, it will be winter time in 13,000 years, and vice versa. So you'd still have the seasons, it's just that the timing of them would be different. Okay, what about the tilt of the Earth? So it turns out that the Earth is tilted currently at 23, but it wobbles a little bit like this. So sometimes it's going to be less than 23 degrees, and sometimes it's going to be tilted more than 23 degrees. Now, what difference would that make? So imagine that the Earth is straight up and down like this. So the Earth is spinning straight up and down. What would the seasons be like? Well, there wouldn't be any seasons because it would always be hot at the equator and it would always be cold up here at the poles. Now, the reason why we have the seasons is because the Earth is tilted. So what would happen if the Earth was tilted even more? Well, the seasons would become more severe, so that winters would be colder and summers would be hotter. Now this has a 40,000 year cycle. So it takes 40,000 years for the Earth to make one wobble in its tilt. All right, let's take a break, and when we come back, we will discuss some other things that might influence the climate of a planet.